We have Jean-Christophe Pineault, who is pre-sales engineer at EMEA. Is that correctly pronounced?
Yes, ATEM.
ATEM, okay.
Yeah.
So Jean-Christophe is a broadcast solution engineer at ATEM with expertise in new technologies, including HEVC, ultra high definition, 4K, and MPEG-. He has an engineering degree from École d'Ingénieurs de Brest in France. And after initial experience with Nokia as a core network technical support engineer, he joined Envivio in 2008 to work on deployment and support for compression systems. He moved to Nagravision in 2010 to work on conditional access systems and content management systems, architecture design and deployment. 2 years ago he joined ATEM and is responsible for complex video project management. Over the years, Mr. Pineault has been engaged in multiple deployment projects, assisting service providers and broadcasters in their adoption of advanced broadcast technology. I will hand over very quickly, and we'll try and make it the time. You've got 50 minutes, so let's see. Thank you very much.
Hello. So this presentation was supposed to be done by my colleague Charlie Bercier. She was supposed to be the woman quota of the speaker today. Unfortunately, she's not available for personal reasons, so I take over. So I hope you're not too disappointed. So today I'm going to talk about new television technologies with the introduction of HEVC on ultra high definition TV. I will try to answer questions such as, do we need to go beyond HD? What benefits should we expect, and what are the implications? And can new compression technology improve the customer user experience within today's network constraint? So the agenda, I will start with definition of this new technology and standard, give you a status of standardization, and introduce you with some concepts of these new technologies. And in a second step, I will talk about market adoption, give you some feedback about the first experiments done this year, and give you some perspective for coming years. Okay, so what is ultra high definition TV, and what does it mean compared to HD? So it means higher resolution, 3840 pixels by 2160. That means 8.3 megapixels, 4 times the full HD resolution. That means not only higher resolution, that means also higher frame rates, 50 or 60 frames per second to begin, and then later 100 on 112 on 20 frames per second. That means also more colors, a color depth of 10 bits, which means 1 billion colors, and later 12 bits, which means 68 billion colors. And also a new color gamut compared to HD. New standard will be named BT 2020 and is aimed to cover more than 75% of the human vision. In a second phase, we'll introduce high dynamic range in order to allow a greater dynamic range of luminosity, and also immersive audio going beyond 5.1. We are talking about 7.1, 11.1, new standard like AC4 or MPEG-H Part 3, which are object-based audio. So, first of all, UHD TV is more immersive. With current HD, the classical field of view is 30 degrees. With UHD TV, bigger screens, and also now curved screens, the average field of view will be around 60 degrees. Why do we need more frame rates? One application is to reduce motion judder, like you can see on this picture. It's very annoying to look at this kind of video, of picture. The second application is to reduce motion sensibility. You can see at 50 frames per second, you can't read at all what is written. Going up to 100 and even to 300 frames per second, you can clearly read the text during fast camera movement. So why 8-bit is not enough? The human eye is more sensitive to certain color, like dark blue. In this color space, color gradient is very annoying. On using 10-bit color depth, you can reduce a lot this gradient for a better user experience. Color gamut. So today in Uhdtv, we are using very little subset of what the human eyes can see in terms of color. It's called BT709. The next standard, BT2020, is supposed to cover more than 75% of the human vision, adding more color like pure red or going to the green on blue level. HDR, why do we need it? First application is to increase the luminance in certain use case, like when it's dark scene. It increases a lot the user experience to have a 1% luminance instead of clipping luminance. In standard dynamic range, you can have what we call low light. That means the scene is overexposed. At the opposite, you can have high light. That means the scene is underexposed. That's not beautiful at all. And what you can do with high dynamic range is to have better contrast, and the result is that the whole scene is correctly exposed. Now, HEVC, which stands for High Efficiency Video Codec. It's a successor of the H.264 MPEG-4 HEVC codec. It's a joint standard by ITUT and ISO MPEG. The goal is to achieve 50% bandwidth saving against H.264 with some constraint, maximum 10 times more complexity for the encoder, or maximum 3 times more complexity for the decoder. So how do we achieve this 50% bandwidth saving? With some new tool. The main difference is the coding structure. In H.264, there was only one kind of macroblock with a size 16 by 16. In HEVC, we introduce the coding unit, which we can go from 8 by 8 to 64 by 64 pixel. The coding structure is also much more flexible in HEVC than it used to be in H.264. And also for more efficient spatiotemporal movement prediction, HEVC now supports up to 35 intra-prediction direction, opposed to the maximum 9 intra-prediction direction in H.264. So one illustration of the implementation of these new tools. with this image, where you can see easy part of the image, like the blue sky, are encoded using 64 by 64 block. On a complicated part of this picture, like the edge of the kite, like the waves, are encoded in a block of 8 by 8. This tool alone represents almost half of the compression gain compared to H.264. So that was a presentation of the technologies. Now I will talk about standardization. So standardization bodies are working on defining what is UHD TV. ISO ITU are defining the baseband format. SMPTE and HDMI are defining the baseband transport. And DVB, AR, IB, and SCTE are defining the end-to-end solutions. So what is it? Two definitions. Phase 1, which is today, and phase 2, which will happen in the near future. So phase 1 standardization is almost finished. Resolution is 4K with a maximum frame rate of 60 frames per second. It's progressive only. It's Rec 709 with BT 2020 optional and discourage. And the codec will be HEVC 8-bit and 10-bit. Phase 2 will address higher resolutions, that means 8K. Wider color space, BT 2020 will be mandatory in this phase. Higher frame rates, we think 100 or 112 and 20 frames per second. Introduction of high dynamic range, scalable video codec, and more improvement to come. But UHDTV is not only video, but also audio. Dolby has introduced the successor of AC3, named AC4. And MPEG also proposed a new audio codec, MPEG-H Part 3. This audio codec are object-based. What about 3D? No effort in phase 1 for 3D video. It will be side by side, like in HD now. And no audio features, no 3D audio features will be implemented in phase 1. What about transport? So MPEG is working on a new transport mechanism, MMT for MPEG Media Transport, aiming to replace transport stream, TS. HDMI 2.0 supports up to 4K 60, so it's already ready for phase 1 only. And dash standardization is ongoing, and we've got no news for HLS update to support 4K. What about application standards, which define complete solutions? So ARIB bit 32 is already available. Same for DVB, standard TS 101.174 version 1.12.1. We suppose SCT will follow soon, and then ATSC. Deployment phase. So this drawing is 1 year old, but it's still up to date. Phase 1 with experiments in 2014 and 2015. We will see experiments until end of 2015 on first deployment, not before this date, maybe beginning of 2016. Phase 2, not before 2018, on what will be called UHD 2, with introduction of 8K, not before 2020. Now, HEVC standardization. The version 1 has been standardized in January 2013 with final publication in April on the availability in June last year. Done by ITU, which call it H265, on the ISO, which call EMEA Part 2. 3 profile, main profile, classical consumer application, 8-bit on 420. Maintain profile, premium on UHD application. That means the addition of 10 bits. On the still picture profile, which is an idea picture on a subset of the main profile. It's an ongoing process. Already 3 extensions or amendments were done since the publication of the first version. The last one this month for range extension called REXT for the addition of 422 on 444. More than 10 bits now, 12 and also 14 bits. More color support. Back in July 2014, there was an amendment for scalable extension called HEVC. And in April, there was an extension for multi-view. So validation work has been performed to assess the usability for a large range of applications. We validate the performance on the bitrate gain of 50%. It is already achieved, especially on 4K progressive content. Efficient interlace techniques were developed without additional tools compared to the original standard, which was at the beginning designed only for progressive. And now we can measure gain of about 40% in 1080i. So what are bringing the guidelines? The aim is to ease interoperability. So only constant frame rate on 16:9 aspect ratio. Mandatory signaling to help decoders in HD. Those signalings were only optional. I'm talking about aspect ratio signaling, color space also. Very important to help decoders do its job. Ensure compatibility with other standards, of course, MPEG transport stream, but also to liaise with ATSC on SMPTE to ensure compatible guidelines. And no major change in the broadcast chain. Multiplexer, ID inserters, splicers are expected to be easily made compatible. So the bitrate gains in progressive content using objective measurement like PSNR are between 40 and 60%. The gain is higher in 4K resolution like, than with a smaller resolution like 720p. Here you've got an example with a soccer game, 720p 50. Where we can measure a gain of 43%. For 1080i with subjective measurement, the bitrate gain is around 50%. Like I told before, if you are using objective measurement, we are more about 40%. But subjectively, 50% is a very good result. And if we are talking about legacy SD content, the bitrate gain is around 30% using PSNR. An example of comparison between H264 and HEVC. with a 1080p sequence encoded at 2.7 megabit per second. You can see great improvement around the edges for the detail of the faces. And globally, there is less blurriness and more sharp details with HEVC. So another comparison using a video with, okay, so a 1080p sequence encoded at 5 megabit in H.264 on 2.5 megabit in HEVC. So the 50% bandwidth saving HEVC is promising. So basically, you can't see any difference between the left and the right, except maybe the color is sometimes a bit different. But in terms of video quality, it's totally comparable. So it's very interesting for OTT player, IPTV operator to be able to bring full HD to a lot of final user with a bitrate of only 2.5 megabits. Okay, short video. So that was a presentation about technology standards on gain for HEVC. So now we're talking about market driver, market adoption, experiments done during the year. There was the World Cup. We've done some experiments at the French Tennis Open, during the Commonwealth Game and the Asian Games last month. A big year for sport fan. So market trends, screens are booming. Now 4K TV are widely available. You can find Samsung 4K 50-inch less than €1,000. I'm not sure how it makes in pounds, but during the last months the prices decreased a lot. A lot of second screens, tablets, phablets, mobile phone, PC, laptops. Now producers are thinking about second screen when they design new programs, already thinking about content monetization on the second screen. So HEVC is driven by industry optimization to enable new services in various markets. For OTT and multi-screen, the aim is to reach more customers and reduce the CDN cost. For telcos, the aim is to bring HD in every home. And for cable, satellite, and DTH operators, the aim is to attract more customers. UHD is driven by enhanced experience, better visual experience, especially for sport content with a higher frame rate. Innovation drives market leadership in the broadcast market, and the traction from TV industry, of course, for the market growth. So HEVC is a new vehicle to enable new service, and 4K is only one service among other services. Another big sign from the industry is Apple announced last month for the new iPhone 6 to support H.265. You know, Apple has a lot of market share in mobile phone and tablets. So when they decide to adopt a new standard, it's a good market driver. So there is two application to field for UHD TV. On the contribution domain, we are still using MPEG-4 in order to be open to this ecosystem, and it's more event-based, like for big sport events. For broadcast, UHD TV is already using HEVC. The aim is bandwidth efficiency and customer reach. And it's more easy to move to HEVC fast because of the fast device are going on the market, new TV supporting natively HEVC decoding, so it's more easy than in the contribution market. Example of the World Cup, the contribution solution put in place to transmit the signal. So there was 3 games produced in 4K during World Cup. So it was made available to the encoders through 4 times 3G SDI links, encoded by 2 dual channel encoders, then multiplex in MPTS with 4 services, between 20 and 25 megabit each services, to reach at the other side 4 decoders, of course synchronize each other, to allow decoding of these 4 quadrants of the 4K signal, and to be outputted with 4 times again 3G SDI links. So then this signal decoded from the contribution decoder could be put on software encoders to encode in UHD P50 at 35 megabits per second, and was sent to Eutelsat satellite in DVB-S2 modulation, and was decoded in some French theaters, outputted thanks to 4 HDMI cable to a theater projector. Experiment has also been done in UK, thanks to the BBC. They posted a very nice article on their blog that I encourage you to read, telling them the experience they got using this signal. And they made also a very special VIP event on the top of the BT tower for the final game. Little earlier, at the French Open Tennis, French Open Tennis is well known to be an experiment for new technologies. So last year we did dailies at Roland Garros, broadcasting in 720p 50 HEVC. This year we took a new step, broadcasting live 1080p 50 HEVC. During some days there was producing facilities with 4 UHD camera, new UHD TV facilities, 4K encoders, 4K set-top box, and of course here Samsung TV, also with HEVC decoding capabilities. It was broadcasted on satellite, terrestrial, and IP networks. Example of the satellite architecture. So the same as for the World Cup, 4 3G SDI input to a software encoder. This time bitrate was done to 28 megabits, sent to the same Eutelsat satellite, and received at different locations at the Roland Garros lab, at Eiffel Tower Champ de Mars, and it was made available throughout Europe because the signal was not encrypted. So everybody in Europe with a proper TV set was able to decode and to watch this content. In Korea, they launched UHD TV channel back in April 10th. It was made by HomeChoice, a leading content aggregator in South Korea. So it's 4K P60, HEVC main profile, TS at 32 megabit, video at 30.5 megabit, Dolby stereo audio, running from 6 a.m. to 2 a.m. with 40 original programs in a loop. The aim is to have, at the end of the year, at least 100 programs. It's a mix of film, documentaries on sports. There is also 3 free-to-air experimental trials in South Korea with licenses given by the government until end of this year to cover metropolitan Seoul. That means more than 25% of the population. 4K P60 broadcasting using DVB-T2 modulation at bitrates between 25 and 27 megabit per second. The big traction was the Asian Games hosted in South Korea last month. In both cases, the viewing is primarily on Samsung and LG HEVC capable TV set-top box that are not really ready yet. So the architecture of the terrestrial trial, same encoder, this time 30 megabit, and since modulation to go to DVB-T2 network on display on Samsung and LG TV with DVB-T2 demodulator integrated. So still work is done, the decoding and display work is done on the TV, not yet on set-top box. Red Bull is not only energy drink, it's also a famous sports sponsor and also TV content producer, mostly for its extreme sport. They produce some content in their famous Hangar 7 studio in Salzburg in Austria. So last month they started producing in UHD TV using cameras operating at 50 frames per second. The content this time was encrypted with BIS and was broadcasted on the Eutelsat satellite. And there was a demonstration on the IBC show on the Eutelsat booth with the IDC Pro Cinema 4K decoder. It was a really nice demonstration with very nice content from Red Bull. So the UHD broadcast solution currently in place, it's a mix of offline broadcasting and live broadcast. There is not so much production live in 4K now, so most of the content broadcasted are offline content. So the file sources are encoded using offline encoders to be put on a playout database for 24/7 broadcasting. During special event, there is also a live encoder with 4 3G SDI links we have seen before, encoding in real time in HEVC. This time only 8-bit. 10-bit is not ready yet for real-time encoding. We put a video recorder in order to keep file of this content to be broadcasted later on. The live stream is broadcasted in real time. We can also use raw capture of the content to encode directly with the offline encoder for a better quality for rebroadcasting. Checking the time. I think I'm faster than my predecessor. So, what have we learned during this first experimentation? The good thing is we can broadcast UHD TV quality at bitrates down to 11 to 12 to 18 megabits upon the content complexity. Of course, here I'm talking about offline content. 11 megabits, it's more for 24 frames per second for movie. Like we've seen with the experiment I showed you before, for live transmission at 50 or 60 frames per second, we are more between 25 and 30 megabits per second. Interoperability seems to be much more easier than the beginning of H.264. We work closely with the TV vendor, set-top box manufacturer. They got content from the encoder vendor to be sure the interoperability will be easy and will be fast. So the first experiments show it's working well. The broadcast delivery needs little or no modification. We were able to broadcast on the DVB-S2, DVB-T2 network without a lot of work to do. And most important, the user experience is very promising. It remains challenges. We hope to gain at least 10% efficiency over the next couple of years. HEVC is still in its infancy. H.264 is mature and has been improved a lot since the beginning of this codec. The interoperability is still based on a common understanding between vendors. That means we can't guarantee any encoded stream will be correctly decoded without testing. That's why we provide a lot of content to TV vendors, set-top box manufacturer, just to be sure it's working well. Sometimes we need to modify a little bit algorithm. Can be on the encoder and decoder side to be working correctly. And of course, UHD TV market penetration will be led by content availability. I would like to conclude with this curve showing what happened for both HEVC and UHD. Last year, HEVC was standardized. There was a peak of expectation with this promising new compression algorithm, promising 50% bitrate saving. Early this year, Orange announced they were going to broadcast in HEVC during summer. They made some experiments during the first semester, and they realized it's not so easy. There's not set-top box ready. The interrupt with the TV is not so smooth. So this year was mostly experiment. But we believe next year will be the launch on first production services in HEVC started with OTT. UHD TV this year with a lot of sport events. There was a lot of expectation, a lot of trial of tests were made during this sport event. The results are promising. But we believe next year will be too soon for a real launch of this new format because the ecosystem is not ready. There is no standard for uncompressed UHD TV signal. We are still using 4 times 3G SDI links, which is not optimal. So we believe next year will still be experiments and trials, and we see first deployment end of next year and maybe beginning of 2016. So that's it. Thank you.